All right, so good morning or good afternoon. This is Mr. Goyaso, and as y'all can see, today we are talking about parallel and perpendicular lines. This is the third day we're talking about it, so y'all should have a pretty good understanding of parallel and perpendicular lines so far. And we're just going to take everything that we've learned a step further. So for these first couple of examples, as y'all can see, 1 through 4, I want to write the parallel and perpendicular slope for each equation, okay? So our first equation is y equals 3/4 x minus 4. So the parallel slope for that's the easy one, right? Parallel means we have the same slope. So for number 1, my slope is 3/4. So my parallel slope, also 3/4. Easy, 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 okay? Now, perpendicular, okay? Perpendicular, it's a little different. Perpendicular slope is the opposite reciprocal of 3/4, okay? So what that means is I flip the 3/4 upside down and I change the sign. So instead of a positive 3/4, the perpendicular slope is going to be negative 4/3, right? We flip it, change the sign, okay? That's all we do. Number 2, negative 2/5 x plus 2. So again, parallel, easy. You just keep the same slope, which is negative 2/5. So I write negative 2/5. Again, perpendicular, opposite reciprocal. We flip and change the sign. So negative 2/5 is going to change to a positive 5/2. Okay, that's it. Number 3, y equals 4x plus 7. Again, parallel, same slope. So my slope here is 4, which means the parallel slope is also going to be 4. Okay. And perpendicular, again, opposite reciprocal. So if y'all remember, when you have a whole number 4, we can actually write that as 4/1. Okay, that means the same thing. So if I want to write the opposite reciprocal of 4/1, the perpendicular slope is going to be negative 1/4. Okay, so just remember that whenever you come to whole numbers. Number 4, same thing. Y equals negative x minus 3. Again, just like right from the beginning, we can remember when we have an x by itself, there's an imaginary 1 there. So it's like negative 1x minus 3. Okay, you can write it in if you need to. I always do. So again, parallel, same slope. So my slope here is a negative 1. So parallel slope is negative 1. Okay. Perpendicular, again, when we have a whole number, like we do here, right, it's a 1, we can write that as over 1. So the perpendicular slope to negative 1/1 is actually positive 1/1, or just 1, okay? So that one's a little funky, but once you write it out, it makes sense, okay? So we have a parallel and perpendicular slopes. This should be just a review, okay? Now, for the new stuff we're doing, to take a step further, what we want to do here in this first section, example 1 and 1b, we want to write the slope-intercept form, okay? So remember what slope-intercept form is. It's y equals mx plus b, okay? We want to write the slope-intercept form for an equation of the line that passes through the given point, so like this, and is parallel. So that means it has the same slope of the equation given, okay? So what I want to do, what they're asking me to do, is write a new equation that's parallel to this equation and goes through this point, okay? Now, the easiest way that I've found to do this is to actually use the slope-intercept form, the equation. So let me show you what I mean. So the first thing we want to do is we're going to label everything, okay? Just like we've been doing for the past couple weeks, actually, in my class. So I want to label my x value, and I want to label my y value, okay? And I want to make sure I label my new slope. So my new m, okay? So since this line, my new line that I'm writing is going to be parallel, that means it's going to have the same slope as my given equation, which is 4. So my new m, my new slope, it's still going to be 4, okay? Now, What I want to do is plug this information, my x, my y, and my new m, into this slope-intercept form, okay? So watch what I mean here. So instead of y, for now, I'm going to actually substitute y, right? We don't usually do that. Usually we plug in m and b. But for right now, I'm going to substitute in almost everything. So just watch how I do this. So instead of y, I'm going to substitute in my y, which is 2. So 2 equals m, my m is 4. So 4 parentheses x. I'm going to substitute my x, which is negative 2. Okay? And now I'm going to have the plus b at the end. Now this b is what I want to solve for, okay? And that's going to give me an equation that has a slope of 4 and goes through those 2 points, okay? So y'all see what I did? I plugged in the x that I was given, I plugged in the y that I was given, and I plugged in my new slope. And I'm going to find the y-intercept, the b, okay? So at this point, what I want to do is I want to, let me kind of write this on the side here, is I want to solve for b, okay? That's what we're doing here. We're solving for b. So let's do that, right? We want to get the b by itself. So to get the b by itself, I need to first multiply these two, right? So I get 2 equals 4 times negative 2, that's negative 8, plus b, okay? Now, to get the b by itself, right, I need to undo this minus 8. To undo that, right, we can draw a little line here. To undo that, I'm going to add 8 to the right. What I do to one side, I do to the other. I'm going to add 8 to the left, okay? So I get 10 equals b. Okay, it's kind of small. So I have 10 equals b, okay? So what that tells me is my y-intercept is 10. So my new equation, right, this is my b, this is my new b, okay? And I'm going to use my new m, which is 4, and my new b to make my new slope-intercept equation, which is going to be y equals 4x plus 10. Okay? That's an equation that's parallel to this equation, right? It has the same slope. And this equation goes through this point, negative 2, 2, right? That's why I plugged those in, okay? If we plugged this x value in for this equation, or sorry, in for this x and substituted the y here, it would make a true statement, okay? And we'll see that later when we look at some more graphs, okay? Let's do 1b. So for 1b, I have the point negative 2, 4, and I have the equation y equals 3x plus 5. So again, I want to write a new equation that's parallel to this and goes through that point. So we label our x and y, right? And I'm going to label my new slope. So my new m is going to be parallel, so it's going to stay the same. It's going to be 3, okay? So now I plug what I have, my x, y, and my m, into slope-intercept form, right? And we're going to solve for b, just like we did. So I have 4 equals 3 parentheses negative 2 plus b, right? Instead of y, I plugged in 4. Instead of m, I plugged in 3. Instead of x, I plugged in negative 2. And now we're going to solve for b, okay? We're going to do the same steps. So we're going to multiply on the right. So I get 4 equals 3 times negative 2. That's negative 6 plus b. And I'm going to switch to a capital B because my 6's kind of look like b's. So I'm going to switch to a capital here. Let me write this here. There we go. Okay. Now, we solve for b, right? One step. Draw a little line. To undo negative 6, we're going to add 6 to the right. What I do to one side, I do to the other. So I get 10 equals b, right? Again, this is my y-intercept. So my new equation is going to be y equals 3x, right? My new y-intercept plus 10. So this equation is parallel to y equals 3x plus 5. And if I was to plug in these points, or if I was to plug in negative 2 for x, my y would be a 4. So that'd give me a true statement, okay? So that's parallel. That's the easier one. Let's try this bottom one, okay? So perpendicular. So what we want to do here for 2 and 2b is we want to write a slope-intercept form equation, so still y equals mx plus b, that passes through this point, right? Same thing so far, but now it's perpendicular to the graph of the given equation, okay? So I want to write a line, so I want to write a new equation that's perpendicular to this one and still goes through that point, okay? So a lot of the steps are still going to be the same, right? I'm still going to label my x, I'm still going to label my y, and I'm still going to label my new slope, okay? But this time, since it's perpendicular, my slope is not going to be 1/2, okay? I have to write the opposite reciprocal, okay? So the opposite reciprocal of 1/2 is going to be -2/1, which is just -2, okay? So that's my new m, my new slope, okay? So now, just like we did before, I'm going to plug my x, y, and my new m into the mx plus b form, okay? So instead of y, I'm going to plug 2, so 2 equals m, my new m, which is -2, parentheses x, plus b. I'm going to write a capital B again, okay? Just because my b's look like 6s. Okay? Now we solve for b. So we do the same steps, right? We multiply this first. So I bring down 2 equals -2 times 4, -8 plus b. Okay? Now, I want b by itself. So to undo -8, I'm going to add 8 to the right. What I do to one side, I do to the other. So I get 2 plus 8, 10 again, equals, that cancels, that's a 0 pair. And I get b by itself. So I get 10 equals b. Okay? So now we write our new equation, just like we did. But now I need to make sure I'm using my new slope, my new m, because I want this equation to be perpendicular to this one. So y equals -2x, and then my b is 10, so plus, 10, there we go, plus 10. It slipped on me. There we go. So this equation, y equals -2x plus 10, is perpendicular to y equals 1/2 x plus 1, and this equation still goes to the point 4, 2, right? If we were to plug in 4 for my x, my y would be 2, okay? Y'all can try that on your own if you wanted to, but that's it. So 2b, we'll do the same thing, okay? So we're going to label our x and y first, and I'm going to label my new m, my new slope, okay? So my old slope was -3, right? And we can even write -3/1, because that's going to help us later. And I want to write a slope that's perpendicular to -3/1. So we have to do the opposite reciprocal. So the opposite reciprocal of -3/1 is a positive 1/3. So that's my new slope, positive 1/3, okay? And now, same thing. We plug in our x and y and m into the slope-intercept form, solve for b. So let's do that. We get -2 equals 1/3, parentheses 6. Oh, it's a 6. Oh, it's a bad 6. There we go. Plus b. Use the capital B again. Okay? And we work down. So, first things first, bring that down. Multiply 1/3 times 6. That gives me a positive 2 plus b, right? We want to solve for b, so I draw my little sign here. To undo a positive 2, I'm going to subtract 2. What I do to one side, I do to the other. -2 minus 2, well, that gives me a -4. That gives me a 0 pair, so I have -4 equals b. Okay? So my equation, using my new slope, is going to be y equals 1/3 x minus 4. Done. So again, this equation is perpendicular to this one, right? And if I was to plug in 6 for x, my y would be -2, okay? So that's that. Now let's go to the back side. Let's flip to the back. Okay? So here on the back, we're going to look at some kind of, I guess, special cases. So here what we want to do is we want to write the slope-intercept form. So the same thing for an equation of the line that passes through the given point and is parallel, so right here, parallel, so we want same slope, to the graph of each equation, okay? Now, we'll do the same thing. Let's start it the same way. So I have -4, that's my x, 1 is my y, okay? But looking at this equation, y equals 3, that is a special type of equation, right? We've talked about that equation. That is a Hoy, remember? Because it's a y equals a number, so that makes it a Hoy, okay? So what that tells me about the slope of this line is that it is 0, right? Since it's a y equals a number, that tells me it's a 0 slope, the 0 slope for this equation. So if I want to write a line that's parallel, my slope, my new slope, so I'm going to say my new m up here, is going to be 0, okay? My new m is going to be 0 because this is a Hoy equation, okay? So when my slope is 0, it's really easy. We don't have to even plug it in and solve for b and all that stuff, okay? It's really easy. Now, if my slope is 0, right, and it's parallel, if my new slope is 0, that means my equation is going to be y equals, right? And then whatever y value it needs to go through, right? So my x is -4, my y is 1. So my new equation is going to be y equals 1, okay? This equation, y equals 1, is parallel to y equals 3 and goes through the point -4, 1, okay? We can graph that. So just so y'all can see it. So y equals 3, that's a horizontal line at 3. So it looks something like this, okay? And now I'm going to plot the point -4, 1. So -4, 1 would be right here, okay? And the equation that I'm saying is going to go through that point and be parallel is y equals 1. So if I was to graph y equals 1, that would look like this. Okay, so if y'all look at those two lines, they're parallel, right? They run side by side, they never touch, and it goes through the point -4, 1. So we saw this is my correct answer, okay? I know these are a little tricky, but the special cases are always a little tricky. But we'll see a couple more examples. So on 3b, same type of thing. So I need my new line, or my new equation, to go through the point 3, 4, okay? So I'm going to label that x, label that y, and it needs to be parallel to the equation x equals -2, okay? So right from the start, since my the equation they give to me is x equals -2, I know that is a Vux equation, right? Because it starts with an x. It's x equals some number, okay? So if it's going to be parallel, that means it's going to have the same slope. So my new m, or my new slope, is going to be undefined. I'm just going to write UND. Undefined, okay? Because this slope, right, since it's x equals, that slope's undefined. My new slope is still going to be undefined, okay? Which means my new equation is going to be x equals some number, okay? Now, if we look at number 3, right, my slope was 0, right? It was the same slope. It was parallel. This equation was y equals 3. My new equation was y equals 1, right? They're the same, parallel. And I found what y equaled by looking at my y value, okay? So we're going to do the same thing with the x's, right? It's parallel, so they both start with x. But to find the number, I look at my x value, which is 3. And so that's my equation, x equals 3. Okay? And we can graph that, and I can show you. So I'm going to graph x equals -2 first. So it's a vertical line at -2. Looks just like that. Okay? And now I'm going to graph the point 3, 4. So 3, 4, it's right there. Okay? And then now I'm going to graph x equals 3. So I can see if it's parallel, and it goes through that point, and as y'all can see, it is. So those two lines run parallel, they run side by side, they don't touch, and this equation is x equals 3. So that is correct. okay? So now let's slide down to 4. Okay, so 4, again, y'all can kind of see where this is going. So on 4, what we're doing is we're doing the same thing, writing equations in slope-intercept form, but this time that are perpendicular to the given equation, okay? So if y'all look, you can kind of see a pattern, right? In number 3, when they were parallel and they were these special cases, this was y equals 3, this was y equals 1, right? Those are parallel. In 3b, parallel, x equals -2, x equals 3, okay? They're to start with the same letter. So when they're perpendicular, they're actually going to start with the opposite letter if they're these special cases, okay? So right here for number 4, I want my point or my line to go through the point 2, 3. So that's my x, that's my y, okay? Now this slope right here of y equals 8, that's a Hoy. So my slope is 0, right? But I want perpendicular. So my new slope, my new m is going to be undefined, right? Because we want the opposite now. We want the opposite of the y equals 0. So that's going to be undefined. So instead of my equation starting with the same letter, my new equation is going to start with an x. Y'all see that? Because it's perpendicular. So it's going to be x equals, my x value is 2, x equals 2, just like that. Okay? So again, I can show you all with the graph. So I'm going to graph y equals 8, so that would be up here. And I'm going to graph 2, 3. And I'm going to graph x equals 2. And look at that. Perpendicular. Right? Remember, perpendicular on a graph means they cross at a 90-degree angle, which these do, and it goes to the point 2, 3. Perfect, okay? So just remember, when you're dealing with special cases and we're finding perpendicular, it's going to be the opposite. So if my equation is y equals 8, opposite, x equals, my x value is 2, x equals 2, okay? Same thing for number 4b, or yeah, I guess letter 4b. So 4 is my x, -5 is my y. This slope, right, x equals 3 is undefined. So my new slope, my new m is going to be 0, right? It's going to be the opposite. So the opposite of x equals 3 is y equals some number. My y value is -5, y equals -5. That easy. And again, we can graph all that. So I'm going to graph x equals 3. That's right here. I'm going to graph the point 4, -5. And I'm going to graph the line y equals -5. And again, we are right because these two lines are perpendicular. They make a 90-degree angle. And my blue line, y equals -5, goes straight through that point that we wanted it to. Okay? So that's it. So again, the special cases are a little tricky, but just kind of review the notes, practice a little bit, and y'all will be fine. Okay? If y'all have any questions, y'all can ask your teacher. But other than that, y'all have a great day, and I'll see y'all later.